Thank you for joining us. Welcome to the Brick Smart Sewers webinar. Did you know that the EPA estimated that it would cost $630 billion to overhaul our wastewater industry? That's one of the reasons we're here today. I'm Katie Strauch, Marketing Coordinator at KCI Technologies, and I'm the moderator for today's webinar. I'm joined today by my colleagues Catherine Brill, Senior Product Manager, Jay Kwan, Sales Engineer, and Carl Keller, Senior Systems Engineer, Innovator, and Expert in Artificial Intelligence, and leader of our Machine Learning Operations team. It's our pleasure to talk to you today about the evolving role of artificial intelligence in the wastewater industry. In the next 30 minutes, we'll cover key topics such as critical challenges in wastewater, why we are applying artificial intelligence to the challenges of defect detection in sewer pipelines and sewer remediation, a brief overview and demo of Brick's machine learning models that are specifically designed for wastewater processes. By the end, you'll see how AI can optimize your engineering processes and help you to provide the best possible services to your clients. We'll save time for questions at the end, so feel free to drop them in the chat. Let's get started.
Okay.
Now I'll pass it over to Catherine, who will be talking to us for a few moments about challenges in the wastewater industry currently.
Thanks, Katie. I jumped the gun on that. Thanks, everyone. Thank you so much for joining us. So our products team here at KCI, we are committed to developing and bringing to market emerging technology for users within the larger architecture, engineering, and construction industry, including water. And as we started our product development process, we consulted with our own wastewater engineering experts within KCI. We talked to clients. We also did a lot of market research. And what we found was some pretty alarming statistics on the status of our wastewater infrastructure in the United States. So on this slide, you'll see I threw up some quick stats for you to peruse. Basically, there are 2.2 million miles of sewer pipes in the United States, and unfortunately, about 23 to 75,000 sanitary sewer overflows are occurring every year. The EPA estimates that we would need about $630 billion to overhaul our wastewater infrastructure over the next 20 years. So here are some key pain points that wastewater utilities, municipalities, cities need to face. First is aging infrastructure, also infrastructure failures due to deferred maintenance. And then lastly, I wanted to point out some climate hazards, specifically something called green swan events. So these are happening more and more often, unfortunately. They are large-scale, high-impact environmental catastrophes that are caused by climate change. So unfortunately, Hurricane Helene that happened last fall, that is a perfect example of a green swan event. In that, with that hurricane, the wastewater treatment plants were overloaded and untreated sewage was released. So as you can see here on this slide, that there are a variety of pretty dire consequences of wastewater systems being kept in poor condition, including water quality issues, our environment being contaminated, properties being damaged, public and private. There's these kind of issues really have impact on local and state economies, and also they just negatively affect our quality of life. So it's become very apparent that the need for municipalities and utilities to fully understand and get a comprehensive view of the true condition of their sewer pipes is critical. But this high demand for sewer inspections is creating a very large logjam of data that needs to be analyzed and evaluated. So that's where we came together as a team and thought, how, if we could automate parts of the workflow and help for easy generation of actionable insights, how would that help? Well, it would help utilities with their proactive maintenance. It would help save them money from costly repairs that they need to make. And it also would shield the general public from environmental hazards. Now I'll pass it back to Katie.
Thanks, Catherine. I'm going to talk with Carl Keller, our AI SME, about how AI can help optimize processes and reduce costs for wastewater clients. Carl, can you share why AI is a good fit for the NASCO workflow?
Sure. Thanks, Katie. Well, there are a couple of aspects of the NASCO workflow that point toward automated solutions like AI. First is the data collection inspection process, which is done now with CCTV cameras and operators who are knowledgeable of the NASCO standard and label the video accordingly so that we have a very well-defined set of detections and their codes that we're looking for. So that helps in building an AI system, particularly for something like vision, because you have those classifications already set up by experts in the industry.
Thank you. What types of AI are good fits for the different parts of the workflow?
So I already mentioned the vision end of it. We actually, and you'll be seeing a demo of this, apply machine vision to the very front end, the data collection end, and particularly the post-collection analysis that's done by wastewater engineers. So everybody here, I'm sure, knows that the CCTV data is the primary source for defects starting out. And that has to be reviewed by a wastewater engineer. The tools that we have in Vision are aimed at making that process less taxing and easier for a wastewater engineer. We both identify and track features as they appear in the videos, and you'll be seeing a demo of that. The second area that's important from an AI standpoint is that there is business policy associated with generating recommendations for how to remediate pipelines. So that business policy, in our case, is captured in a rule-based system, which is an older technology, kind of a well-worn technology, I would say, for policy automation. And so that's what we use a little farther down the workflow pipeline. And I'll talk about kind of the intermediate stuff here shortly.
Okay, thank you. And I believe you briefly touched on this already, but what's the connection between CCTV video and inspection data that drives the generation of cost analysis?
Okay, this is another area where NASCO, I think, is really performing well for the industry. So, for example, you know, the CCTV video is going to be annotated with detections from the NASCO classes that we see. Those NASCO classes and the inspections themselves then are captured in a NASCO standard database in a couple of tables, the inspection table and then the conditions table in NASCO for PAC-P. So those two sets of data, both the video itself for helping a wastewater engineer analyze what's going on, and then also, or confirm what's going on, and then also the data that shows up in the database become the grist for the mill as far as both the recommendations and the pricing, which is the cost analysis that we're referencing here. So the way that works is, people familiar with NASCO, you get your detections, you generate a set of grades. Those grades yield a set of metrics that you can look at. And the metrics are an abstraction of what's really going on, you know, in the pipe and provide this higher level description of it. From there, our rule-based system policy picks up on both the defect types and also the actual metrics that have been computed in each of the inspections. and then provides recommendations to remediate those, and those recommendations then are tied to pricing tables that are actually configurable and allow you to price the recommendations that have been generated.
Thank you, Carl. Lastly, can you explain where NASCO grades and metrics come in?
Yeah, and I kind of hit on that a little bit. As everybody knows, I think the defects are the highest level, I guess, of detail, and the metrics are kind of the summary level of detail. But in between, there's a grading process, and when you have defects, the defect can either be something that is solely existing in the pipe, an individual defect, I would call that, or they can be defects that have length, for example, longitudinal fracture in a pipe, or they could also have an orientation within the pipe. So a clock face positioning, and the clock face itself kind of has a duration around the clock face associated with it. That impacts grading, and we take that into account. And then finally, there's also the amount of obscuring that goes on by the defect. So for root balls and those kinds of things, or DAGs, you can see a lot of obscuration of the pipe, and so that's also captured. And these all form kind of magnifiers, if you will, within the grading and metrics process. So it's not just individual defects we're detecting. We're using all of the data from the inspection database, which shows up in the condition table.
Thanks, Carl, for that. I'm going to take over. This is Catherine again. And now that we've gotten really great information from Carl about how AI can be used within the wastewater sector, I wanted to talk to you about what we've done with Bricks. So Bricks is our cloud-based, secure, scalable model-as-a-service platform that provides easy access to pre-trained machine learning models. Those models can be run on demand directly from the Bricks platform or integrated with third-party systems via APIs. Bricks provides a ready-built infrastructure to allow engineers to do the kind of analysis of CCTV data that Carl was just describing in bulk via batch processing. So the next part of our webinar is to give you a demo of some of Brix's solutions. So I'm going to switch over. One second. I'll try to move this over. Yes, everyone should now be able to see the gobricks.com interface. If you can't, please let me know. Somebody raise your hand. But you'll see that this is the marketing homepage where you can see a variety of information about Bricks. And when I click on catalog, you'll see all the pre-trained models that are ready to run and available for use now. You can filter by the specific industry that you are interested in or search by name. For the purposes of this webinar, I have logged into our test environment to show you the two models that we have for the wastewater industry. So the first one is that I'd like to talk about is our sewer pipeline defect detection model. This is a computer vision model that analyzes CCTV data and automatically detects and classifies the defects found in that data using NASCO standards. So this is designed to, as Carl had mentioned, really optimize the engineering workflow of having to review and QC the inspection data that comes back from the operator as part of the process of delivering insights and actionable recommendations to a client. So to run this model, it's very simple. Bricks has been designed to be as intuitive as possible. You use our data sets feature here to upload your CCTV data. And then when you're ready, you click on the Run Model button. And here I'm going to select my data that I would like to run through the model. And Bricks does some validation. And here you'll see that I can enter a identifying name for this model run. I can choose whether I want to process either still imagery or video of the CCTV inspection. We support both. And here I can also set another metric. This precision recall metric is very common for computer vision models. And we're allowing you as the end user to configure this for your model run. So if you want the model, for example, to pick up all possible defects, you would move this slider over more towards quantity, but you can also adjust it so you can tell the model to pick up relevant defects. And so you move it up to quality. So we give the user that kind of flexibility as they are configuring their model run. So let's see. So once I'm done with that, I can start my model run, review my parameters, and click Run Model. Now, the results of this model can be found in our Results tab. You can see here I can download my results and also view them depending on which model it is. For the purposes of this webinar, I've got everything downloaded that I wanted to show you. So let me go to this video. You see here, this is an example of one of our sewer defect detection annotated video output. So I'm going to start running it, and you'll see pretty soon that the model is finding defects, outlining it with a bounding box, and coding it with NASCO standards. So here, if I want to, I can speed this up, really speed up the workflow so that I can very easily confirm and QC that all the defects in the sewer pipes were correctly captured by the inspector. Not only does this model output annotated imagery and video, but it also outputs a summary report. So I'm moving that over here now. You should be able to see it. And here I have listed all of the defects that were found along with their confidence level, their name, and their timestamp. We've also aggregated those defects, so rolled them all up based on class and tracking ID, and that's found in my aggregated detections tab. And then even we have one other tab called detections count, and that totals up all the defects, the number of defects that were found in the data, in the CCTV data. So that's a very good example of what is outputted for our sewer defect detection model. And now I want to go back to Bricks and start talking about smart sewer repair. So this is the next step of the puzzle. So once you've QC'd as a wastewater engineer, project manager, once you've QC'd that inspection data, then you need to really think about how to generate repair, replace recommendations along with cost estimates so that clients know exactly how to budget and plan. So that's where smart sewer repair comes in. It is analyzing NASCO databases. So you would upload your NASCO database, as I have here, into your Bricks platform, and then you start your smart sewer repair model run, select your database, and then enter a unique name for your model run. And you can even modify the pricing to suit your specific region or area. And then when you select next, the model starts analyzing that NASCO database. Now this is a knowledge-based AI solution that really helps optimize that engineering workflow of generating recommendations for clients, along with cost estimates. So again, the results can be found here and downloaded from Bricks for very easy access. And the last thing I wanted to show you was an example of an input file, a sample NASCO database, and what Bricks is generating with smart sewer repair. So you see here, this is an example of a NASCO database that we've got. You see in this case, we had 6 inspections. And when I click on PACP conditions, you see all the defects that were found. And once this file is run through the smart sewer repair model, this is an example of a file that is generated. So you see here, everything is laid out very nicely, well organized by inspection ID. We have information on inspection date, location, pipe width, pipe height. More importantly, we've got grades by code listed here, as well as, if I keep on going, likelihood of failure for that section, recommended repair, priority, and total price. So you can see with this information, it has everything that the engineer needs in order to help prepare that report for their clients. So I'm going to go back to the PowerPoint and hand it over to my colleague, Jaquan.
All right, so thank you for Kathleen Cowles to showing what is the bricks in terms of technology, and especially for our 2 model for sure, right? So now I'm here to supporting that if you're using the bricks, especially for our SURE model, we can definitely helping you to save time in your project. And once you save time in your project, obviously you can also save the money in the projects too. So this is something that we talk internally. Our practical water engineers are using our bricks and compared to when they are using it, when they are not using it in terms of projects. So when you look at this time saving graph over here, the average of the projects that it will require to do it without using the bricks platform takes about, each project will takes about 40 hours, where if you're actually using it into bricks, it would take about 20 hours. So we can definitely helping you to save 50% of your time on it. And when you are saving a time, obviously you can actually do more projects. So as you can see here in this graph, it shows you that you will win more project, you can do more inspection, where you can also see the also saving the money in how much you'll be able to spend money on this. So every case will be slightly different. So therefore, I'll be the one that will be discussing with you, helping you which license option might be a good fit for you guys. So now we'll be hearing, now you get to understand what is the bricks, what is our SOAR model, and now and some of the price information. So now we're here to take the questions from you guys. Katie or Kathleen, do you see any questions?
I don't see any come in. So while we're waiting, maybe we can talk about our blog. Oh, here's a question that's coming in. Sorry. The question is, have studies demonstrated a clear advantage in accuracy, efficiency, or cost savings over conventional inspection and grading processes? Is there anyone from the team who wants to take that one? Okay, I can try to, let me turn my camera on. I can try to address that. We have worked incredibly closely, and I'm sure that Carl can join in on this, with our wastewater engineers, to find out exactly where their pain points are when they are dealing with handling recommendations for their wastewater clients. And one of them definitely was those hours and hours of having to manually watch videos to confirm that all the defects were found. So that's where our sewer defect detection computer vision model really comes into play, because that is speeding that workflow entirely. As far as the grading processes, our understanding, and Carl, actually, you probably have even better understanding of this than I do, but our understanding is that to come up with recommendations manually is pretty time consuming, involves combing through reports, past reports, and looking for information manually. So that's where smart sewer repair comes in as well. I hope that has answered your question. Carl, do you have any further insight you can share?
Sure, I could jump in a little bit on this also. One of the pain points that was highlighted by our subject matter experts, who are wastewater engineers within KCI, was that not only the analysis of the video, but just the processing of the data, in the workflow, from defects to grades to metrics to recommendations to pricing, is a very lengthy process. And if you've got many inspections in a particular project, it can be quite time consuming. It creates a backlog, and there's oftentimes more than one of these things for any given expert on the team. So our ability to number one, compute the grades from the data, number two, compute the metrics correctly associated with the NASCO implementation, and then combine that based on their business policy into a set of recommendations and pricing has saved them an enormous amount of time. I don't have an exact number of hours, days, weeks, but I do know that these are tasks that can take multiple days to execute, just to get to the point where you have that costing spreadsheet together. So obviously in the demonstration, I don't think it's starting end-to-end run, but the system executes extremely quickly to come up with an answer for this. So
Thanks, Gary.
our internal folks have been very excited to use it on their own work.
Thanks, Carl, for that. And we've got another question coming in. What's the cost to run each of those models? Great question, Seth. Bricks runs on we do have a subscription, but Bricks, we're trying to be as flexible and add as much convenience as possible to you guys. So it's a pay-as-you-go licensing model. So, thank you, Jay. Jay just put in our pricing. You can run any amount, as large amount of data as you want, and the model consumes a certain amount of credits based on which model it is. And each time you run a model, then those credits are consumed. We've averaged it out. For example, I believe with the sewer defect detection model, if you run the model 4 times a month, so once a week, then it would cost anywhere between $400 to $600. It really depends on if you're a subscription user, then we have a benefits to being subscription, though it doesn't cost as much. Are there any other questions? Oh, we had something in the chat. Oh, here's PriceLink. Thank you for doing that. I want to say before we hand it, I know we're over time, but before we hand it over to Katie for goodbyes, I just want to say that we just published a blog on blog.gobricks.com about smart sewer technology. So please, we would love it if you checked it out. Let us know what you think. So Katie, I'll leave it to you now. Thank you.
Thank you. That brings us to the end of today's webinar on the AI in wastewater industry. We hope you found it valuable and insightful. A huge thank you to our speakers for sharing their expertise and all of you for joining us today. We encourage you to visit gobricks.com to view our catalog. And please contact Jay Kwan with any additional questions. His email address is up on this slide. And also please follow Bricks on LinkedIn. Thank you again for your time and participation. We look forward to seeing you at our next webinar. Have a great day.